Welcome back for lesson 22-3. Today we're going to be using trig ratios to find unknown sides in right triangles. So make sure you're open to page 312 in your book, and you must have a scientific calculator today for today's lesson. Okay, so let's start by looking at these two triangles here. For each of the following triangles, determine the ratio requested. Then use a scientific calculator to evaluate each trig function. Okay, for y, round your answer to the nearest tenth. So let's look at A here. In A, they want us to find the sine of 41 degrees. So if we remember our trig ratios that we learned yesterday, remember we have SOHCAHTOA. So sine uses the opposite side in the hypotenuse. Cosine uses the adjacent side and the hypotenuse. And then tangent uses the opposite side and the adjacent side. So SOHCAHTOA. Okay. So in A, they want us to find the sine of 41 degrees. Well, here's 41 degrees. So the sine, I would use the opposite side, so y, over the hypotenuse, which is 100. And now we need to solve this for y. So the easiest way to do that, in my opinion, is to think of this like a proportion. Okay, so if I put that sine over 1, then I can cross multiply these. So 100 times the sine of 41. And then y times 1 would just be y. So the rest of this I just need to do in my calculator. So we're just going to punch 100 times the sine of 41 in our calculator. Now before you do anything, make sure your calculator is in degree mode. So go hit mode, make sure degree is highlighted. Because if it's not, you're going to get the wrong answer every time. So we just have to type 100 sine of 41. And we round to the nearest tenth. So 65.6 is the answer. Okay. So I'm going to have you guys try B. B wants you to find the cosine of 28 degrees. So the cosine, you're using the ca. So set up your proportion and solve it for y. Okay, if you did it correctly, it should have been cosine of 28 was equal to 18 over y. So they found the decimal here first for cosine, and then again, kind of like cross multiplied this to solve it for y. So 20.4 was that answer. Okay. All right, let's look at number 2. So it says, use your knowledge of trig functions to find the value of x in this triangle ABC. So they want us to start by choosing an acute angle. So we have our right angle at B, A and C are our acute angles. Now I'm just going to choose angle C since there's the measurement there. We could choose angle A if we wanted to. We just have to do a little subtraction to find what that angle is. But let's just choose angle C. Instead of choose one of them, that's the one I'm going to pick. Okay, so in angle C, they want us to solve for x. That's the end goal. So let's look at where x is and how we could solve that. So for angle C, it looks like x is opposite of angle C. And we're also given the length of the hypotenuse. So we know the opposite side and the hypotenuse for angle C. Well, opposite and hypotenuse would be using the sine function. So we're going to use sine here. Okay. So write an equation. We're going to kind of skip to D here. Write an equation to find x. So we would have the sine of 20 degrees, because that's how much the angle is equal to opposite was x over the hypotenuse, which is 15. So this is similar to the one I did before. Think of this as over 1, and then we can cross multiply these. But x then would be equal to 15 times the sine of 20. So go ahead and punch that in your calculator. What do you get for x? If you did it correctly, I got that x was 5.13. And if you're not getting these answers, just double check, make sure your calculator is in degree mode, because that really will affect a lot of your problems. Okay. Let's just finish up on this page. So it says, use your knowledge of trig functions to find the value of y. So A is just kind of more of a setup question, but I'm going to have you guys do B. Use the sides to choose an appropriate trig ratio, then write an equation, solve for y. So look at what you're given. The end goal is to figure out what the length of y is. Okay. So choose one of your acute angles, set up an appropriate trig ratio, solve for y. So go ahead and try this 3b for me right now on your own. We'll see what you get. Okay. If I was doing this problem, I would probably do the 10-degree angle. And if I do that, you are given the adjacent side and the hypotenuse. So adjacent and hypotenuse would be using cosine. So this is how I probably would have done the problem. But you could have also done the sine. You would just have to figure out the measure of angle E, which was 80 degrees. So there's two ways you could have done it. It doesn't matter which way you do it because you can see the answer is the same for both of those. Okay, let's just wrap up here with question 4 and then we are done. So a 12-foot ladder is against the wall, okay? The ladder makes an angle of 75 degrees with the floor. So let's just make a diagram here. So we have a wall. Let me do this. And there is a ladder, 12-foot ladder, leaning against it. So here's my ladder. And they said it's 12 feet. Okay, so they said that this ladder, okay, against the floor makes an angle of 75 degrees. So use the information to draw and label a right triangle. I did it. Let's look at B and C. We're going to find the distance. Okay. Oh, actually, we have to do B first. My bad. We got to do B first. Set up and solve an equation to find how far up the wall the top of the ladder reaches. So basically, this length. So set up a trig ratio and see. So let's look at what we're given. For 75 degrees, I'm given the opposite side. It's across from that angle. That's what we're trying to find, which is x. And I know the length of that ladder was 12. That's my hypotenuse here. So opposite and hypotenuse would be sine. So finding the sine of 75 degrees equal to opposite over hypotenuse. So go ahead and solve that for x for me and see what you get. Okay, when I solved it in my calculator, I got 11.6 feet. So I round to the nearest tenth. If you round it a little different, your answer should be close. If you're a little off, not a big deal. Okay. So letter C then says find the distance from the base of the wall to the base of the ladder. Okay, so we found this was 11.6. So now they want you to find the distance from the base of the wall to the base of the ladder. So figure out how you can set up a problem and solve for that. Okay. Well, one way you could do it is if you take that y side would be the adjacent side and the hypotenuse. So you could have done cosine of 75 equal to the adjacent over the hypotenuse. Okay. Another way you could have done the tangent. Okay, the tangent of 75 would be the opposite side, which we just found was 11.6, over the adjacent side, which is y. Okay. Or a third way to do it is if you use Pythagorean theorem. So y squared, okay, plus 11.6 squared is equal to 12 squared. Okay. All of them are going to give you some decimal, but it's 3 different ways to do the problem. If you did it correctly, you should have gotten that y here. It was about 3.1 feet. Okay, so this whole lesson is just using trig functions, so setting up a ratio to solve for different lengths of the triangle. So as long as you know your SOHCAHTOA, you should be able to set up any problem.